Hello, once again I welcome you to our comprehensive course in data engineering. It's very important to build the foundation in order to crack a data role. SQL and database acts as the foundation or the key components when you work with data. By understanding these key areas, you will develop a thorough understanding of data engineering principles and practices. In this video, we are going to learn about basics of SQL and database and understand the importance of learning SQL and database. Let's get started. So let's take a look at the agenda. In this video, we are going to cover why should you learn about database and SQL, what is a database, we'll learn about key features of a database, and then we'll understand the importance of database in modern computing. We'll look at different types of databases, and finally we will learn about the history of SQL and relational databases. This will help us really understand why SQL is designed the way it is, right? And how it's adapted to different eras of computing. So we'll first understand why learning database and SQL is super important, right? So before we jump in, let's quickly define our terms and let's understand what is a database and what is SQL. So a database is like a super organized cabinet, right? That's a digital cabinet where you can store vast amounts of data, vast amount of information. And SQL is nothing but its structured query language, which is a language using which you can talk to the databases, right? It's like you can ask questions and you get answers from the data. So in a simple example, you can think of a database as a massive library, and SQL you can understand as a librarian, right? Who knows exactly where every book is and can find any information you need in within seconds, right? So we are living in a data explosion, right? Every day we are creating about 2.5 quintillion bytes of data. That's 18 zeros, right? That's huge. So from social media posts to online purchase, from weather sensors to stock market transactions, data is everywhere, right? Let's take the example of Netflix. They use massive database to store information, right? They store information about every show, they store information about every user or every viewing session, right? So when you see those recommended for you sessions, that's SQL. It looks at terabytes of data to find shows you might like. Companies today are all about data driven decision making. They are using data to perform various tasks like predicting trends, understanding customer behavior, optimizing operations, developing new products. Amazon uses database and SQL to analyze purchase history, browsing behavior, and even inventory levels, right? Even to check inventory levels and decide what products do we need to recommend to the customers and what to stock in their data warehouse. Let's take a look at the career opportunities. So learning database and SQL opens up a lot of career opportunities. And there are a lot of roles such as data analyst, business intelligence specialist, database administrator, data scientist, data engineer. These roles are in high demand across various industries. So whether you are interested in finance, healthcare, tech, or entertainment, they all need data experts. And you know what? SQL is universal, right? So once you learn it, you can work with pretty much any relational databases out there. Whether a company uses MySQL, PostgreSQL, Oracle, or Microsoft SQL Server, your skills will transfer. So when I worked for a telecom project, we used Oracle as our main systems. And when I moved to a different project, there we started using Microsoft SQL Server. So I could jump in right in. And right away I started working with their data too, because SQL is universal, right? Once you learn SQL, you can apply it in MySQL, you can apply it in PostgreSQL, you can apply it in Sybase and other different database systems. Now we will take a look at and understand the main thing, right? Why SQL is important, why learning SQL and database is important. So using SQL, you can carry out a lot of tasks, right? You can combine data from multiple sources. So as a data engineer, you need to combine data from multiple sources. You may connect to different upstream systems and ingest and get data from there, right? And then you can filter out exactly the data that you need. So that's a feature engineering, or let's say about the data transformation task that you need to apply. You may perform complex calculations as part of your task. You can use SQL to identify trends and patterns. So these are some of the things because of which SQL, understanding SQL and database is of utmost importance, and we must understand the basic concepts of SQL and database. So the basic concepts are straightforward, and with practice you can quickly start writing powerful SQL queries. So what exactly is a database? Let's understand the formal definition of database. So as per ANSI ISO, which is SQL standard, a database is a collection of data typically organized to model relevant aspects of reality, right? So this definition from SQL standard, it emphasizes the role of database in representing the real world entities and their relationships. We are going to see the relevant examples and later on, and we'll understand this in detail. Now let's take a look at another definition of a database. As per NIST, which is National Institute of Standards and Technology, a database is a collection of related data that's organized in a way that allows efficient storage and retrieval of data. This definition focuses on two main features. The first one is efficiency, and the second one is ease of data access. Now we'll understand with a real world example. Imagine you need to store a lot of stuff, toys, books, tools, kitchen utensils, sofas, and more in your house, right? So if you put them randomly anywhere in your house, will it be easy for you to find any item when you need it? Of course not. You will have to go and scan each corner of your home to find a single item. Hence, you like to keep the things organized. Let's say if I ask you to find my office bag, I don't think you will be able to find it, right? You need to organize your things if you want to find it easily, right? You keep your kitchen utensils and spices etc in your kitchen. You don't put them in your bedroom, isn't it? Because it's easier to locate and use the items when required, right? So database works in similar way. It keeps the data organized. It keeps everything in its place, making it easy to store and find what you need. So this is a very good example. Now this house is very well organized, and if I ask you to find my office bag, of course you will be able to find it within few seconds, right? That's how the database works. Knowingly or unknowingly, you interact with database on daily basis. Think about Amazon, right? That's an e-commerce platform. So every time you use Amazon, when you use when you search for a product, you are actually querying their product database. When you add items to your cart, you are updating a temporary order database. And when you complete a purchase, you are modifying their inventory database, order database, and customer database. So now let's take a look at some of the key features that make database so powerful. The first one is they store data efficiently. It allows massive amounts of information to be stored in a relatively small space. Second one is it enables quick information retrieval, right? Imagine finding a specific order among millions, right? A good database can do this in few seconds or in milliseconds. They maintain data integrity that ensures that information remains accurate and consistent. They also support and serve multiple users simultaneously. It allows many people or the systems to access data at the same time. And the last but not least, they provide security and access control. That's very important. It ensures that the sensitive information is only accessible to the authorized users. So these features make database essential in our data driven world. So now that we have understood what a database is, let's talk about why they are crucial in today's digital landscape. So database serves as the foundation for numerous applications, right? Let me give you some examples. So let's take a look at the business operations. Companies like Uber rely heavily on databases. They use them to match riders with the drivers, calculate fares, and manage trips in real time. Without these databases, existing of such service we can't think of, right? Simply that service could not function. Now let's take a look at the data analysis. Think about Google Analytics. This is a very powerful tool, right, that processes vast amounts of data, and this data is stored in databases. What's the work of Google Analytics? It provides insights on the web traffics, and it also provides the user behavior, right? It provide you the trends and the user behavior. So this kind of analysis helps business make informed decision. And the next one is customer relationship management. Salesforce, a leading CRM platform, it uses very sophisticated database, and it helps business manage their customers interactions, right? And also the sales part. So this allows companies to provide personalized experience to their customers. The last one is social networking. Platforms like Facebook and LinkedIn use complex database systems to manage user profiles, connections, and content. So every post you see, every friend suggestion you get, it's all powered by databases, right? So now let's explore different types of database being used in the industry. Each type has its own strength and uses. In some scenario, you may use relational database. In another scenarios, you may use non-relational database. So let's understand what is relational database. We'll start with the most common type, right, which is a relational database. Relational database organize data into tables, which contains rows and columns. It's like an Excel sheet. I think on day-to-day basis, we all work with Excel sheet, CSV file, right? Microsoft Excel. So the relational aspects come from the ability to establish relationships. Right? So that's the definition of relational database. Let's go back to our Amazon example and look at the type of business they have. You can expect various tables, right? So one of the main table will be products table. So product tables will contain information about each item they sell. There will be one customer table, which will basically contain details about customers, and then there will be order table that tracks all the purchases, right? These tables are all related, right? So when you make a purchase, Amazon can easily connect or join your customer information to the products you bought and create a new order entry. Some of the popular relational database management systems include MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. These are widely used across various industries. Now let's talk about NoSQL database, which is also known as non-relational database. NoSQL stands for not only SQL. These databases are basically designed to handle large volumes of unstructured or semi-structured data. They have gained popularity in recent years due to their flexibility and scalability. Right? There are mainly four types of NoSQL databases, and we are going to see all these different four types of SQL database. The first one is document database. We'll first understand what is a document database, right? It's also known as document oriented database or a document store. It's a database that stores information in documents, right? So this kind of database stores data in flexible JSON like documents. A great example is MongoDB, which is used by companies like Google and Uber for certain applications. Document database are ideal when you have complex data, right? That doesn't have any structure or doesn't feed into a table structure. Now let's take a look at the key value store. A key value store is also known as key value database, which is a type of non-relational database, and it uses a simple key value store, right? It uses key and value to store the data. So it stores data as a collection of key value pairs in which the key serves as a unique identifier. These are the simplest NoSQL databases, right? They store data as key values pairs similar to a dictionary. Amazon's DynamoDB is a prime example, and it's widely used in various AWS services. Uh, this key value data store it's fantastic for caching and for storing user session. Now let's take a look at wide column store. Wide column store is also known as extensible record store, which is a column oriented DBMS, which is database management systems. It uses tables, rows and columns. But unlike a relational database, the names and format of the columns can vary from row to row in the same tables, right? So this database is optimized for queries over large data sets. Google Big Table is a good example of wide column store. Big Table powers many Google services like search and maps. It's a well-known example, right? So these are particularly useful for storing and processing vast amounts of data across multiple servers. Now let's take a look at a graph database. So instead of tables or documents, a graph database stores nodes and relationships. Data is stored just like you might sketch ideas on a whiteboard. So these are designed to handle highly connected data, right? Neo4j is a popular graph database. It's used by many organizations like NASA for managing complex relationships in data. They are excellent for social network, fraud detection, and recommendation engines. So we have seen from these examples, NoSQL database are powering some of the world's largest and most innovative companies. They are handling everything from social media interactions to space explorations, or from ride sharing logistics to aircraft manufacturing, right? Now we are going to focus on the history of SQL and database. So our journey begins in 1970. So that time Edgar F. Codd, an IBM researcher, published a groundbreaking paper, and the title of the paper was A Relational Model of Data for Large Shared Data Banks. This paper introduced the relational model, which forms the basis of SQL and relational databases. So what did he propose? The Codd model proposed organizing data into tables, which he called relations. He suggested to use mathematical set theory to manipulate this data. This was basically a complete shift from earlier database models, right? And then in 1974, IBM began System R, which is a project to prove the viability of relational model. So as part of this project, Chamberlain and Redmond developed a language to update and retrieve data that's stored in System R, right? So they called it SQL, which is Structured English Query Language. It is SEQUEL, right? SQL was later shortened to SQL due to trademark issues. And the goal of SQL was to create a language that was close to natural English and which will make it easier for the non-programmers as well. In 1979, relational software which is now known as Oracle Corporation, it became the first company to commercialize SQL technology. They released Oracle V2, right? That's the first commercial SQL based DBMS. Right? And IBM, despite inventing SQL, was slower to market. They finally released SQL and DS, their first commercial relational database, in 1981. In 1986, the American National Standards Institute, which is ANSI, published the first standard for SQL. In 1989, Microsoft and Anston collaborated to release the SQL Server 1.0. Right? So this period saw a rapid adoption of SQL in the business world. And in 1995, MySQL was released, which became widely used for web applications. And in 2009, Amazon, right, which is AWS, Amazon Web Services, launched Amazon RDS, which supports various SQL databases including MySQL, PostgreSQL, and Oracle. And right after a year, in 2010, Microsoft Azure SQL database, a cloud version of SQL Server, became available. And in 2011, Google Cloud SQL was introduced. It initially supported MySQL. So now you must have understood that SQL has a rich history that spans over 5 decades. So from its origin in IBM's research lab to its current status as the common language of data, SQL has continuously evolved. And it has evolved to meet the changing data needs, right? So let's take a look at the trends and developments. So we learned that the initial phase started with the release and commercialization of database, and then it later on moved towards the open source database, and now these days we have many database offerings on the cloud. Now we have come to the end of the sessions. So in our next session, we will start diving into SQL and begin writing our first query. Thank you so much for your attention, and I look forward to our next session. Thank you.